Hi and welcome to the second part of managing file permissions and ownership. In part 1 of this module we discussed the change mode command with the different types of setting permissions, which was the octal mode and the symbolic mode. In this second part we will start with the setuid bit, the setgroup bit and the sticky bit. And then we'll cover the umask command and we will finish with change owner and change group. But first the setuid and setgroup bit. Imagine you're logged in as Henry with UID 1001, for example, and you run any external command. The shell will be forked and the command will run in that child shell. Because Henry is running his processes with user ID 1001, the child shell will also run with 1001 as the effective user ID, as it's called. Effective simply means that this UID will be used to execute the command. Sometimes, however, it may be necessary to have more permissions than Henry has. For example, Henry wants to change his password. This password command needs to update the file that stores the user's passwords. Unfortunately, Henry is not able to change that file. That file name, by the way, is the shadow file in etc. We will discuss user administration in a later module, but as a preview, the shadow file in /etc contains the encrypted passwords of all users. We do not want Henry to be able to read the contents of that file, let alone write the file. So how is Henry going to change his password if he has no permissions on that file? This is where the setuid bit comes in. If the setuid bit is set on a binary, the child shell that executes the binary will have the user ID of the owner of the binary. So now, since root is the owner of this password command, the shell that Henry will start will have the UID 0 as the effective user ID and thus is able to update the password file. Once the command completes, it exits and Henry will be back in his parent shell with user ID 1001. So in short, the setuid bit will run a child shell with the effective user ID of the owner of the binary, and very often this is root. The same goes for the setgroup bit. Henry's effective group ID will change when he runs a command that has the setgroup bit set. So let's see how that works. First, we see that we're logged in as Lin user, who is a colleague of Henry. Let's check Lin user's user ID. Well, that's 1001. Now let's see whether Lin user is able to read /etc/shadow. Obviously he is not. And the permissions say he has no right whatsoever. The super user root can overrule these permission settings, so root will be able to do whatever he likes to this file. Now let's check the password binary. And we see that where the X bit of the owner is supposed to be, we see a lowercase s. This is the setuid bit. Also, we see that the group has the execute bit set, as does the rest of the world. So it's clear that the setuid bit is set, but not the setgroup bit. Now, if we run the password command, Lin user can simply reset his password, even though he has no permissions on the shadow file. Like this. So we enter the password twice and Lin user will have a new password. Now to set the setuid bit and setgroup bit with the symbolic mode, you use the user plus s for the setuid bit and the user and group plus s for both. And to undo them, simply change the plus sign into a minus sign. The octal mode is a little different. Compare the three sets of permissions in line with 421. Then the setuid bit is 4, the setgroup bit is 2, and if you want to set them both, you prefix the permissions with 6, and to unset, use a 0 in front of the regular permissions. Then the sticky bit is used in world writable directories. So imagine you want all users to be able to write to a particular directory. They may accidentally or willingly delete each other's files. To avoid that, you can use the sticky bit. Once the sticky bit is set, only the owner of the directory or root can delete or rename files in that directory that are not owned by the user. So in short, a user can only rename or delete the files that he owns. A very nice example of such a directory is the /tmp. The permissions are read, write, execute, read, write, execute, read, write, execute, but now a T on the last X. So in line with the regular permissions, this would be 1 if you would have to octally represent it. Now we disable it by running O-T in symbolic mode, and we list it again and we see the T is gone. Next thing, we are going to enable it again by running change mode O+T, and it's back. To do the same thing with the octal mode, we use 0777 to disable it, and then we run change mode 1777 after we've checked it, and we will have enabled it again. Now the umask command is a command that can set a mask so as to influence the default permissions of files and directories that are being created. The maximum default permissions of a directory is 777, and the maximum default permissions of a file is 666, because a file is not necessarily an executable. So it is most easy to think of it as this. If you set a mask to 022 or 0022, you could subtract that from the maximum default value, and that will then be your default. So in the case of a subdirectory, 022 means 777 minus 022, which gives us 755, and for files this would be 666 minus 022, which is 644. Now it's not advised to change the umask on your machine. And finally, let's have a look at change owner and change group, or chown and chgroup. The chown command is used to change the owner or group, or the owner and group of a file or directory. The change group command is used to change the group. Regular users cannot use these commands because only root can change ownership. Now let's demonstrate that. So I'm logged in as root and I create a file and I name it not mine. So I list it and I see that root is the owner and root is also the group. So I run chown linuser : linuser not mine. This means that the user will be linuser and the second field after the colon will also be linuser. So I list the file and I see that linuser is the owner and linuser is the group. Now I just chown root not mine. So now root is the owner again, but linuser is still the group. So I only changed the owner. Now with change group, we're going to change the group again to root for the file not mine. And as we can see, root is the owner and root is the group that belong to the file. Now a very nice option for the chown command is the capital R option, which will recursively change ownership of all files. So in summary, we looked at the different permissions being read, write and execute. We can set these permissions using change mode in octal and in symbolic ways. We dealt with setuidbit, setgroupID for a different effective user ID, and with stickybit for world writable directories. We set the umask to change the default creation permissions of files and directories, and we used change owner and change group to change ownership. Now, if you like, you can pause the video and have a look at the following commands. Now, if you have any questions, please don't hesitate to contact us.